Bismillahirrahmanirrahim. In this unit, we will solve a practical example of to determine the reverse breakdown voltage. Reverse breakdown voltage is the minimum reverse voltage that causes a diode to conduct in reverse bias. When this voltage is exceeded, the diode automatically enter into the breakdown mode and allowing a significant amount of current to flow but in reverse direction. And generally, we avoid for normal diode, except for the Zener diode, which is designed to work in reverse bias side. We in normal operation, we we do not allow to exceed the current beyond the breakdown voltage. Now, question is that an abrupt PN junction has doping density Na is equal to 5 into 10 power 15 atoms per centimeter cube, and N donor Nd is equal to 10 power 16 atoms per centimeter cube, and calculate the breakdown voltage if E critical is equal to 3 into 10 power 5 volts per centimeter. One thing should be clear that breakdown voltage always occur um, after when E critical reach to the E maximum. And after E maximum, after E critical, our reverse voltage is automatically converted to breakdown voltage. So that's why we equal here E maximum is equal to E critical. You will see here E maximum is equal to E critical. And previous slide, we have already determined the equation for E maximum, which is equal to the under root 2Q and A and D VR and divide by epsilon Na plus Nd, where Q is the charge of electron, Na is acceptor doping density, and Nd is donor doping impurity doping density, and Vr is a reverse voltage, and the epsilon is a dielectric constant, and Na and Nd is acceptor and donor doping density. Now we use standard silicon, so our case epsilon is equal to 1.04 into 10 power minus 12 farad per centimeter, and Na and Nd are given here. So we equalize, then our reverse voltage Vr, it has become Vb. Now we determine the equation in term of Vb, and after simplification, simplified equation becomes epsilon Na plus Nd divided by 2q Na Nd epsilon c square. Up now, epsilon is 1.04 into 10 power minus 12, and Na is equal to 5 into 10 power 15, and Nd is equal to 10 power 16, so it becomes 10 into 10 power 15. So in order to take the common 10 power 15, we put here value of the 10, and 2 is the equation 2, and q is equal to 1.6 into 10 power minus 19, and then we multiplied by na 5 into 10 power 15, and nd is equal to uh, 10 power 16. And after the simplification, we break down is equal to 88 volts. So it means that this equation, that after 88 volt applied in the reverse bias, our pn junction become so large that an electric field becomes the E maximum and E critical, and then diode will follow the reverse bias. Diode experience reverse bias breakdown voltage, and very high current is passing through the reverse direction. Thank you.